In 1944, military aviation was approaching a limit it could no longer ignore. Aircraft were getting faster, engines were getting stronger, and yet the wings that had carried fighters through most of the war were beginning to create new problems of their own. The future of air combat would not be decided by power alone. It would depend on a different kind of wing. Behind that shift was Adolf Busemann, the engineer whose ideas helped explain how the jet age would actually fly. By the final years of World War II, military aviation was moving into a speed range where older wing designs were beginning to show clear limits. Aircraft were getting faster, engines were becoming more powerful, and yet many of the straight wing layouts that had carried fighters through most of the war were becoming harder to trust as speed increased. Pilots could still fly them, and engineers could still improve them, but the margin was shrinking. Drag rose faster, control became less predictable, and the closer aircraft moved toward the upper limits of wartime performance, the more obvious it became that power alone would not solve the problem. That is what makes Adolf Busemann such an important figure. He was not famous because he built a celebrated frontline aircraft. He mattered because he recognized that the next major leap in air combat would depend on changing the wing itself. What made Busemann stand out was that he saw the problem before the jet age fully arrived. He understood that once aircraft moved into higher speed flight, the airflow over the wing would begin to behave in ways that made traditional straight-wing designs less efficient and more difficult to manage. This was not a small technical adjustment. It was a warning that the logic behind many successful wartime aircraft would eventually run into a wall. A stronger engine could push an aircraft faster, but if the wing created too much drag or became harder to control as speed increased, that extra power would not deliver its full value. Busemann's answer was simple in concept and extremely important in practice. The wing had to meet the airflow differently. That idea helped form the aerodynamic logic behind the swept wing, one of the most important changes in modern fighter design. What makes this story so important is that Busemann's work was not just theoretical research with no wartime relevance. His ideas emerged at exactly the moment aviation was beginning to encounter the limits he had identified. Jet propulsion was approaching real combat use, but propulsion alone could not solve the aerodynamic penalties waiting at higher speed. The faster aircraft became, the more wing shapes started to matter. That is why Busemann fits this niche so well. He was not chasing recognition through one famous aircraft or one combat record. He was identifying the aerodynamic rule that future fighter designers would have to respect if they wanted jet aircraft to become more than fast experiments. That is what makes Adolf Busemann such a strong subject in World War II aviation. He represents the engineer whose influence was larger than one machine, one prototype, or one battlefield result. His importance came from understanding that the old wing logic would not hold forever, and that the future of fighter design would belong to aircraft built around a different solution. The real question is not whether Busemann designed the most famous aircraft of the war. He did not. The real question is why one aerodynamic insight about the wing became important enough to help shape the future of military aviation long after the war itself had ended. Adolf Busemann's importance becomes even clearer when you look at what happened after the war. He was not remembered because one aircraft built around his ideas suddenly changed the outcome of World War II. That never happened. His significance comes from the fact that the aerodynamic problem he identified did not disappear when the war ended. In many ways, it became more urgent. As jet engines improved and military aircraft moved into higher speed flight, the limits of older straight-wing designs became harder to ignore. Engineers across the post-war world were now facing the same reality Busemann had already described. If speed continued to rise, wing design had to change with it. That is why his work matters so much. He was not simply part of a late-war design conversation. He was helping define one of the key aerodynamic rules of the next era. What makes this especially important is that Busemann's legacy fits perfectly with the kind of engineering story that often gets missed in World War II history. Many viewers remember the aircraft that fought, the pilots who became famous, or the machines that entered mass production. But some of the most important wartime ideas were not fully proven until after the conflict was already over. Busemann belongs in that category. He represents the engineer whose influence was larger than any single combat record, because his work helped explain how future aircraft could remain efficient as they approached the higher speed conditions that older wartime designs struggled to handle. The swept wing was not valuable because it looked modern. It became valuable because it gave designers a practical path forward when the old aerodynamic assumptions were starting to fail. That is why Adolf Busemann stands out even among strong aviation subjects. He was not a frontline celebrity, and he was not the public face of a famous wartime aircraft. His contribution was quieter and more fundamental. He helped identify why the next generation of fighters would need a different relationship between speed and wing geometry. Once aviation crossed into the early jet era, that insight became impossible to ignore. Aircraft were no longer just trying to fly faster inside the same design rules. They were entering a new regime where those rules had to be rewritten. Busemann's importance is that he understood that transition early, before it became obvious to everyone else. That is what makes this story so strong. Adolf Busemann was not the engineer who built the most famous aircraft of World War II. He was the engineer who helped explain why the future of military aviation would not look like the past. His work showed that the next great leap in fighter design would not come from more power alone, but from a wing built for a different speed reality. The real question is not whether Busemann won the war from the drawing board. He did not. The real question is how one aerodynamic idea about the wing became so important that it helped shape the aircraft that dominated the skies long after the war had ended. What made Adolf Busemann so important was not that he built a famous aircraft, but that he helped explain why future aircraft would need a different wing shape to remain effective at higher speeds. As aviation moved closer to the jet age, engineers were discovering that straight wings, which had worked well through most of the war, became less efficient as aircraft pushed into faster flight. The problem was not simply engine power or pilot skill. It was the growing aerodynamic penalty created by airflow over the wing as speed increased. Busemann understood that if aircraft were going to move faster without losing too much performance to drag and control issues, the wing could not remain unchanged. That is why the swept wing became such an important idea. It was not just a new shape. It was a direct answer to the speed problem that military aviation was beginning to face. The core advantage of the swept wing was that it changed how the airflow met the leading edge of the wing. Instead of striking it head-on the same way it did on a straight wing, the airflow was effectively reduced in its direct impact across the wing's span. In practical terms, that meant the aircraft could delay some of the aerodynamic penalties that became more severe at higher speeds. This did not eliminate every challenge, and early swept-wing aircraft still faced serious engineering difficulties, but it created a much more workable path for high-speed flight than older straight-wing layouts. That is what made Busemann's thinking so important. He was not claiming that one design change would magically solve the future of aviation. He was identifying the direction that would allow aircraft to keep advancing when older solutions were reaching their limits. What makes Busemann especially powerful as a subject is that his contribution sits at the exact point where World War II aviation began to hand control to the jet age. During most of the war, speed gains could still be chased through stronger engines, cleaner fuselages, and careful refinement of existing layouts. But by the later stages of the conflict, those methods were no longer enough on their own. Engineers were beginning to understand that higher speed combat would force deeper aerodynamic changes. That is where Busemann's work becomes more than a technical footnote. His ideas helped define the design logic that later engineers would build around. The swept wing was not just another wartime experiment. It became one of the central foundations of post-war fighter development because it addressed a problem that was only becoming more important with every increase in speed. That is what separates Adolf Busemann from many other names in World War II aviation. His legacy is not tied to one aircraft dominating the battlefield. It is tied to an aerodynamic principle that became essential once aviation crossed into a new speed regime. He helped explain why the old wing could not carry the future forever, and why the next generation of fighters would need a new shape to survive at higher speeds. The real question is not whether the swept wing looked advanced. It did. The real question is how one engineer's understanding of airflow helped create the foundation for the aircraft that would define the next era of military aviation.